Hey guys, welcome back. This is Abhishek, and today in this video we will be talking about hyperparameter tuning in machine learning, any machine learning model, how to do hyperparameter tuning. I will be talking about Optuna from scratch because this is the best library to do hyperparameter tuning in very efficient way and very fast way. This is the state of the art algorithm to tune your hyperparameters. What I will be talking about in this video, I have some objective in this video. I will be using load boost and dataset, and since we know that Xgboost always outperform other algorithm, that's why not always outperform other algorithm, but most time it outperform other algorithm, and that's why we are using Xgboost. And our objective is we will use Optuna to hyperparameter tuning of Xgboost, and I will show you how to do that, and I will also explain every line of code one by one. Okay, so first of all, let's talk about Optuna. So if you haven't used Optuna yet, you have to use first you have to install Optuna by using pip install Optuna. And what exactly Optuna is? Optuna is Bayesian optimized hyperparameter tuning algorithm. And this is developed by some a Japanese company which working on this really very well, and the research on Optuna is really going on, and you can tune you can use Optuna with Keras, you can use Optuna with TensorFlow, PyTorch, XGBoost, scikit-learn, LightGBM. So you can use Optuna everywhere to hyperparameter tuning. So let's get started. So I have done some research on it, and I will show you how I get this result in Xgboost. Before, without tuning, my root mean square error was 3.28, and after tuning it is 2.54. And I have used I will share my own personal experience, and I will share my own trick how to do hyperparameter tuning. And trust me, it's not gonna very difficult, it's really easy. Just stay with me until the end of the video, and I will show every line by line code, and I will share everything. Let's start from here. As you can see that there is all necessary modules I have imported. I hope that this is really very clear. And then I am using load Boston dataset as I have told you. So I will run this, and then just here it's x and y, and then standard scalar. And when we use a tree based model, we really don't know to use standard scalar, but it's really a good practice to use standard scalar. So now what I have done here is we have split our data in xtrain xtest, ytrain ytest with test size of 0.2. Okay, and then what I have done is I have changed our xtrain ytrain into D matrix. Why are we using D matrix? Because we are going to use XGBoost CV and XGBoost train model. Why we are using XGBoost CV and XGBoost train model? Because in XGBoost CV and XGBoost train model, you can use early stopping, so your tree based model will not get overfit, and that's why I am using D matrix. That's why I am creating D matrix, because XGBoost feature supports D matrix. So it's really very easy, just you have to give X train and Y train, and everything will be same. So just do this, right? And then after what I have done here, I have just before making any model, what we basically do, we make a base model to just figure out what is our normal scoring, right? So here I have used our scoring as a negative root of mean squared error, as you see, and I have also created my own CV, which is k-fold with 10 split and random state equal to 0. And then just look at this here, and n jobs equal to -1, since I'm using the Google Colab, doesn't matter. And let it run, and you will see my my mean root mean square error, which is mean, is minus 2.92 and the standard deviation of 0.52. And if you see all the 10 RMSE, you will see it's quite varying, like it depends on split. Our RMSE is depending on split, you can see here. And I can tell this is not good way to do this for Xgboost, because in Xgboost we have also our own Xgboost CV, so we can also use that. But again, it's good, we can use it as our base score is minus 2.92. And then what I've been doing, I am creating a scoring function with the help of Xgboost train inbuilt early stopping. And this is our scoring function. What I have imported, I have imported RE. I will show you why. Just comment it out for now, just comment it out. And we have made a function called return RMSE. It will take parameters, params, and that will be in dictionary, right? And that parameter will be in dictionary. And then here its model equal to xgb train. Here we will pass our parameters, and then we have passed here d train and num boost round. And again I will tell let you confirm that this num boost round is same as our n estimator in sklearn, right? And here it is our evaluation set, which is d test, and I have so given a name of eval. And then I have given early stopping equal to 20 and verbose equal to 0, because we don't need to get our information on each over iteration. And here model dot eval, so I have to pass the same name which I have given here. So eval d test print result. So what it will return, it will give us, our RMSE, right? So what I will do, I will call this function, right? Let's do this. Okay, I am giving return RMSE params equal to, I have not given anything, means our XGBoost will give RMSE on their default parameters. Just run this and you will see I'm getting 3.21 as our RMSE by using XGBoost VB, by using XGBoost. So if you see here, I have given some string also, and in order to remove this string I have used regular expression. I'm using regular expression. And what I have done here is I have used some basic functionality, and you can understand it's really very simple. I have just search with all digits, and it can accept some period or decimal point, and then result I have given the same. And now if I just print, and you will see I will get only this point now. So if we are creating a function, so I have to return result as well. So I will remove this one, I don't need to print now. So now let's move on. So this is our scoring function, right? So in default XGBoost, uh, whenever we will deal with regression, it will return RMSE, and when we will deal with classification, it will give us AUC score. So now what is our next step? We will import Optuna. If you never used Optuna, you have to do pip install Optuna. If you are using Google Colab or Kaggle, you don't need to do that. Pip install Optuna. So you have to do this, and I can run this as well, but it doesn't need you if you are using on cloud. Okay, it's done. Now what we will import, we will import Optuna from trial. What trial does, trial um, trial keep a record of all your answer over iteration. And here I have used visualization to visualize which data are we using, and for visualization purpose I will show you how does it work. And then I am using Optuna.sampler import TPE sampler. What TPE sampler is? TPE sampler is an algorithm. This means a tree pargin estimator sampler. And this is actually a Bayesian optimized algorithm, so that's why I'm importing. Now what we have to do, we have to define an objective function, and it is the same as space which we create in a hyperopt or skopt, and same something like those. So just forget if you haven't know those hyperopt skopt. Let me tell you, hyperopt skopt the same tool for hyperparameter tuning, but they are not really very good. And Optuna is really very good. I have trust me, this is really very good. And now what I have created, I have created an objective function, and I will pass trial. And now what we're gonna do, we will have to give params. And in params I am not using an estimator. Why are not we using an estimator? Because sometime what happens, sometime we give an estimator and it select very high number, and it leads us to overfit, and that's why we are not tuning hyperparameter. That's why we are not tuning an estimator, and we will tune that an estimator by using our early stopping. So what are those things we need to tune? We need to tune maximum depth, and since maximum depth will be always integer, so it will be suggest int. And we have to write the maximum depth here as well, and here 3 to 10, because I want my maximum depth from 3 to 10, right? If it will be a 9, if it will be 10, if it will be 7, then I will increase it from 5 to 25 to 50, and I will do something like that. And then I have given res alpha. Reg alpha means our we can say this is our if you remember, there is something called lambda and there is something called alpha. What lambda is L2 regularization and alpha is L1 regularization. So this is regularization alpha. So here what our alpha will be, trial dot suggest, it will be uniform from 0 to 6. So what uniform does, it will uniformly distribute 0 to 6. It will be, it will just distribute, it will make an uniform distribution between 0 to 6. It is same like this. Suppose I have given 0 to 10, then it will be 1 to something like that, okay? And here we have regularization lambda, and again I will say suggest dot uniform. So suggest dot uniform, okay, suggest dot uniform is again same, and I have given 0 to 2. You can try out 0 to 10, and at first you will give this a bigger range, and after some time, after some iteration, you will make it lower. And then I have given minimum child weight, suggest int, minimum child weight used to be in integer. I have given 0 to 5, and the normal range of minimum child weight is 0 to 10. And again regularization alpha, its normal range between 0 to 5, 0 to 10 it used to be. And regular lambda, it always less than alpha, so it will be 0 to 2 and 0 to 5. And we will use gamma here. Gamma used to be uniform, it can be in decimal, so I have given 0 to 4. It used to be 0 to 10, 0 to 20. You can try out. Just remember what are those values which you have to pass in integer, and what are those values which you have to pass in float. Just remember this one. A learning rate, I am setting my learning rate from 0.05 to 0.5, and it depends on you. You can try out 0.001 to 0.05. You can try out. And I am using here log uniform. Why I be using log uniform? It will make a log uniform distribution. What does it mean? The maximum frequency of trying, will be, okay, just understand on this way, maximum suggestion will be toward the lower value. It means that the maximum suggestion will be toward maximum suggestion will be biased toward lower value, and that's why we are using log uniform. And column sample by tree and subsample. So column sample by tree, it will be 0.4 to 0.9. You can try out from 0.2 to 0.9, and subsample again same story for subsample is, and we are using n thread equal to -1. So let me tell you, these are only those features, these are only those parameters which you only focus on. You don't need to go for column sample by node, column sample by other things. So you don't need to worry about, just focus only on these, right? So then I will return a score. What score I will return? I am returning our this function where we had met here. uh, okay, just wait. Here I have made a scoring function here. So what it will do, what Optuna will do, Optuna will try some features from here, and it will call return RMSE, and return RMSE will give a RMSE value, and on the basis of that RMSE value, Optuna will perform over iteration, Optuna will perform more iteration, and it will try to minimize that value. If I would not return any value, if I will not return any score, Optuna will not work, it will fail. So we have to make a scoring function, and since I'm using Xgboost, so I have used advantage of early stopping, and I made a return RMSE, as you can see here, and I'm returning a score, right? So just run this, and now we have to make a study, since we will do hyperparameter tuning 2 times on the same algorithm, so that we will get them our minimum score, and that's why I have given a study 1 equal to optuna dot create study. So we will create study, then we have to give direction means the score we are getting, what we want to do with that score, we want to minimize, because this is our error which is root mean square error, so we want to minimize that error, and that's why I have given minimize here. And sampler means what algorithm we are using, so we are using tree margin estimator sampler, and that's why I have given here. And now study.optimize is that function which we will call, and our optimization of our error will start, optimization of our hyperparameter will start. So here I have to give our objective function, so which we have created right here, and we have passed objective function. Then we will give you, then we need to give end trial. What end trial means? End trial means how many times we need to do our searching, how many iteration we need to do our searching. And here we have to give so progress bar so we don't get bored, and we can get idea when it will finish, and that's why we have given a progress bar. And trials, I can reduce this to 1000, or to save your time I can reduce this one, and mm, let's reduce this. Okay, I will pause, let this finish. Okay, you can see here our progress bar has started, and you will see here, let me show you. You will see all suggestion by Optuna, and this is trying, our Optuna is trying and building a model with that those parameters, and we are getting value. Right now you focus on this, we are getting 3.13 as RMSE, and now it will now you will see this here is 3.004631, and uh, it will keep reducing, right? It will keep reducing. Now it's 2.9288. So first of all, we are giving this hyperparameter tuning, this is pretty fine, but we have to understand, for a model, for an algorithm, for the minimum, right, for the minimum score, no, for the minimum error or the maximum score, there will be some set of parameters. Suppose what we can do, we should always, right, we, so if we can use grid search cv, we can use random search cv, but our the main process would be the same. What we do, we always find our best n estimator, and then we find a learning rate, right? So we will find learning rate, and then we will find an estimator. We will fix this, right? And then what we will do, we will tune our tree based algorithm, tree based hyperparameters. And what are those tree based hyperparameters? Suppose this is maximum depth, this is regularization alpha, lambda, and minimum child, right? These four, and no, these four, and this is column sample by tree and subsample. So you have to take all those tree based parameters at the same time, and the next time you will select those parameters which are related to regularization like gamma. So what I mean to say that you can do parameter tuning step by step, like you find the minimum, you find the best value of maximum depth at one time, then you find the regularization alpha at the one time. So you can do on this way as well, but my suggestion is first tune an estimator and learning rate, and then go for tree based hyperparameters, and then go for regularization based parameters. We can do on this way whenever we use grid search CV or random search CV. But in Xgboost, whenever we use hyperparameter tuning by Optuna, we can do everything on the same time because it's Bayesian optimized. And but keep in mind that you really don't need to tune an estimator, because calculation of RMSE, calculation of our error, whenever it will calculate our error, so Xgboost automatically set our n estimator by using early stopping, and that's why I'm not using n estimator here. But if you really don't need to, if you really don't want to use this function, you can definitely tune and with n estimator. Now our iteration has completed, and let me show you. So here guys, you can see I'm getting 2.78, and our n estimator is here 236, which we really don't need to look at, because at the end we will tune our n estimator by making a graph of overfitting and underfitting, by looking at our early stopping. So you really don't need to worry of an estimator, right? And I'm using here entral as 550 because 1050 was taking a bit of time and I had really no time. It's 1 a.m. in the morning, and that's why I just reduced 550. Just don't mind that. And now if I go at the bottom of this output, you will see our BIF trial which I'm getting is 2.77, and our n estimator is 432 right now. Okay, so what we have to focus on, we just see the maximum depth and all these parameters. You really don't need to copy this, and because it's in dictionary, and you really don't need to copy this. And I will show you the best trick from now. And our n estimator is this, and the trick is just stay with me, I will tell you, don't worry. So for accuracy, you will just run this, and you will see that 2.77 we are getting minimum as minimum. And if you just want to get our best estimator, so study dot best params, you can do this in this way. Suppose if you are making a model and you want to pass these parameters, so how will you do that? Suppose this will be a model, and what you have to do, just pass the dictionary. It will be study one dot best params. So it will be like this. You really don't need to copy one by one and give some values. You really don't need to do this. Okay, so right now we are getting this as our parameter, which on which we are getting our RMSE as 2.77. This is not accuracy, I'm really sorry for this. RMSE. Okay, so we are getting 2.77. Now this is, now look at this, without tuning and after tuning, what we have got difference. Without tuning we are getting 3.21, and with tuning we are getting 2.77. We are calling the same function which we made for calculating our RMSE by using early stopping, which is our return RMSE function. Now we will plot something. We will use optuna.visualization.plot optimization history. So it will show, it will draw the graph how our value got minimized and our iteration. So we have used 500 iteration right here, and you will see that after 250 our value stopped decreasing. Probably at 432 it got 2.77. And now the best thing, the best plot in Optuna, I think the for the plot which I really love Optuna is this one. Optuna visualization plot slice. This is so what you get from here. What you get from here. This is important thing. You will see we are getting 2.8 as our RMSE by using column sample by tree between 0.4 to 0.6, and this is used to be 0.5. So again we will create a space by using more concise range, right? So here we will use gamma between 0.0 to 1, because you will see the more concentrated gamma is somewhere between 0 to 2, or we can say that 0 to 1.5. Learning rate, we got minimum learning rate as 0.09, and here no doubt maximum depth would be the best option, would be the 4. And no doubt minimum child weight is the best at 0, so we have to fix our minimum child weight at 0. Regularization alpha, it would be somewhere between 0.5 to 4.5, and regularization lambda is somewhere between 0 to 1. Not it is around 0.5, so you can use from 0.4 to 0.6, or somewhere between 0.2 to 0.6. And our subsample is 0.4 to 0.6. So this is again very simple. Now tune again with narrower values, so to get the sweet spot, to get the minimum. So here you will see the minimum maximum depth is 4. So what I will do, I will not give it as range, I will give it at the same number. My bad, I'm really sleeping at this time. And learning rate, it will be okay. What learning rate should we select? It is 0.09, right? So the our learning rate, our best learning rate would be somewhere between 0.9. So that's why I'm using our learning rate in between 0. Uh, 0. Let's say 7 to 0.1. I think it's right. Okay, 0.7 to 0.1. Let's increase it 0.15. 0.15. Okay, and maximum depth is 4. Okay, and minimum child weight must be 0. So minimum child weight is right here 0, and gamma should be 0 to 1, in between 0 to 1. So it can be 2, but I don't think it's 2, so I will remove this. 0 to 1. Okay, minimum child weight and gamma. Learning rate, we have fixed that learning rate. And now column sample by tree 0.4 to 0.6, and here subsample 0.4 to 0.6. It's between 0. Somewhere between somewhere around 0.5, so I have given that value. 0.07 to oh my god, wait, this is column sample by tree 0.4 to 0.6, and subsample between 0.4. It must be 0.4 to 0.5 or 0.6, let's say. Okay, now run this objective function, and we will create our new study as study 2, because we are we did first study by output, we took some output, and we are creating the second study. Now I'm using 550 iteration, and the same, everything is same, just I change the study number. Now run this and here is our so smooth progress bar. and let it finish. Meanwhile, I will talk to you. So if you are using other tool for a hyperparameter tuning, I would suggest you to shift on Optuna, because this is the best and this gives you is visualization. Even Optuna got a new dashboard. You can check out their GitHub link. They have got a new Optuna dashboard, but that dashboard will not work on cloud notebook, so you must need to Jupyter notebook. Okay, so I think we are done now, and let's see our minimum as, okay, we have got our minimum as 2.65 at 530 as our n estimator. So we will plot again. We really don't need to plot again our but let's do this. So you will see our plotting is going this one, and this is our minimum 2.65 at 549 trials. So now we wish to find our best params, so this is our best params, study2.best params. You have to just simply type, and I'm again checking our RMSE how so without tuning it was 3.21, after tuning it was 2.65. Now what we have to do, we are creating our base model. We are if you see this, we are making a validation curve for finding our best estimator and finding our overfitting and underfitting. You can just see this function. I'm using validation curve, and for I in param range I'm giving a param range, and then we are getting some an estimator as I through this loop, uh, and then I'm using train score dot append. I'm appending on these list by append and np square root mean squared error and all these things. I'm not using here uh, cross validation. I'm using only for iteration. Okay, and we are passing our best param by using two asterisk. What it is, keyword argument, so we are using two asterisk here to flatten our dictionary for as a parameter. So here study2 dot best params and our n estimator. So just let's run this, and I hope we are good to go. This is the process for finding our overfitting and underfitting. So as you can see here, our the n estimator must be somewhere between 125 to 150. It must be somewhere between 143 or 140, 140 somewhere, like that. So how to find this one? This is just a visualization, and now this is the process to find our an estimator. So model equal to xgb train study2 dot best params. We are passing again d train, then num boost round. This is our maximum an estimator which we can give us. We can give 1,000, but again we will use early stopping. Sorry. Now just run this, and our minimum our n estimator is here 47, and we are getting 2.63 now, but our model stopped here. But if you want to give if you want to get this point, so you have to increase some patience. This is early stopping round. This is the patience. If we increase, it will not stop just here, it will go for this point to get the minimum. So I will use 100, and let's see what's point now. It will stop. It's stopping at 122 as our best n estimator, which is 2.51. What we got? 122. So it's stopping somewhere here. It's stopping right here. It's stopping right here at this point. It's stopping at this point right here as 122 right here, because you can see that this is the minimum error right here. Now our model is finished. Now we can predict by using this model. How? So we got our n estimator and our parameters. Our n estimator, best n estimator is 122. So we will give here 122, and we will use two asterisks to flatten our dictionary as our keyword argument. So we have used study2.best params, and just run this. I'm also creating a base regressor without any hyperparameter tuning, just to show you what difference we got. And here I'm using the same thing, 122. I'm using fit train and score, base score, fit train. This is very simple, and run this. So without tuning we had R2 as 0.87, and after tuning we got R2 as 0.92. So we got our n estimator as 122 and other parameters also. So the output of this whole video was the hyperparameter tuning, how to use Optuna and how to take advantage of those plots which I have shown you. So our best parameter is best params. So this is our best parameters, and our the best n estimator is 122. So we can train our model again, but since you can see here we have trained our model right here. We have trained our model right here, xgb.train. So we have trained our model right here. You can simply predict by using this. So model.predict, you can use predict and you can pass our data. I'll just say if I see there x test, y test, attribute error, okay, it doesn't support score. Only scikit learn algorithm supports scikit learn model support score, so that's why we got error. So this is all about this video, and if you like this video, please do share and subscribe, and share this video as to your friends and whoever do deep learning, whoever do machine learning. You can share this video, and keep remember that Optuna is the best library for hyperparameter tuning. We can use Optuna for tuning our deep learning model for hidden layers and our filters. We can use Optuna for that also. And this is really nice video, and it's really good to talk to you. And this is my notebook. If you want to work along with me, you can just copy this notebook on your Kaggle and you can work along with me. I will also give you this notebook in my description on YouTube. You can check that out. And thanks for this video. Thanks for liking, sharing, subscribing, and have a good night.